Hello, I am Gary, as you've already been told, and I work here at Kobalt. I do need to start with an apology. I got cornered last week and got asked for a title for this, and I figured container orchestration, most people say ooh, at. It's kind of more this. Basically, Kobalt has done a massive replatforming of its web and mobile infrastructure. But it does include container orchestration, so I will talk about it, it's just not the complete focus. Now, with that in mind, I do need to make a disclaimer. Because it's not just container this is a great start, because it's not, I haven't even had a beer. Because it's not just container orchestration, I'm hoping it'll become quite apparent the amount of research and work that has gone into this. So I'm not going to be going into every single thing in like loads of detail. I will be able to do questions at the end, but if there's anything I don't talk about, you do want to talk, come find me later. I'm more than happy to talk to you about it. So, yeah. So why have we done this replatforming? This, I'm sure a lot of you will recognize, is a fairly simple diagram, although what's probably more likely is that. We're there. We have a bunch of services behind a proxy. We have a monolith that we are currently in the process of trying to split out. We have a couple of mobile clients which have their own mobile APIs. So, does anyone not recognize this? If you don't, you probably want the Salesforce talk downstairs. This is roughly what our infrastructure looks like right now. Now, I did this talk internally a little while ago, and I did ask the question, can anyone see anything wrong with this? I'm not going to ask that because I'm worried you're going to rip into me.
N+1.
Thank you. I think that's probably right, actually, yeah. This on its own is perfectly fine. There's nothing wrong with this. And if this is all we had, we probably wouldn't have many problems. We probably wouldn't need to do anything. However, when I do that, you can probably start to see the problem. Just for the hell of it, does anyone want to take a guess what the problem is?
Everything is done by hand, no automation?
Thank you for being kind. Yes and no. So these are our current issues and concerns. Scalability is a pretty obvious one. The more and more we split our monolith out, the more and more we create projects, the more and more we duplicate this across, which up there is obviously another one as well. We've got duplication of the same infrastructure over and over and over again. The resilience of it. You can see here we've got an EC2 with one container running in it. We don't have any kind of auto-scaling right now. So if one of those containers goes down, we're down to one container, which then requires a manual process to go and kind of give it a bit of a kick, and we'll be back up and running again. The maintainability of it, because this gets copied over and over and over again, one project might have an issue, we've then got to go and debug that and find what else, and blah, 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 blah. You get the idea. Cost is another one. Again, the more and more we duplicate this, the cost is N+1, where everyone shouted a minute ago. And a lot of it's homemade. So for example, our proxy currently is homemade. It's all in code, but it is homemade. So we have Nginx reverse proxy going to each of our services, so on and so on. But we do have a bunch of features within our current infrastructure. We currently support two different portals. If you remember the original diagram, there was actually two clients going into the proxy. Now those two different clients do have differences between them, mostly in the layout and the design, but they're still there. And they use a lot of the same functionality behind the scenes. Because we're using Docker, we have a lot of applications running. So as of now, we've got PHP, Node, Go, Java. I think there's a few Python bits and pieces kicking around, but typically not within this infrastructure, but we do support it. I heard that. We have the capability right now of enabling and disabling particular applications. So those services, if we want to turn one off, so like for example, it's not ready for public release yet, we've got the ability to turn it off, turn a 404, something like that. And we have maintenance mode. So what that means is at the proxy level, we can turn maintenance mode on. Immediately, the users are confronted with maintenance page getting a 503. The infrastructure we currently have does also allow us to internally access our systems while the end user is getting the 503. Very, very useful, especially when maintenance mode usually means either we're releasing something or something is broken. We're trying to figure out what the hell's going on. So, what? So we've seen the issues, we've seen the features. What are we going to do next? Some prerequisites. I was wondering if that showed me the next slide, because that would really help. Some prerequisites. So we need to support the current features. Like, any time you rebuild something, if you deliver something to someone with a feature missing, they're going to go, why the hell is that feature missing? We had it before, why have you taken it out? So we need to support all of those. We need to address the issues and concerns. We need to move to this new infrastructure, ideally without any downtime. Or if downtime is required, it's done in a maintainable way, in a controlled way. And star is code, because everything these days has to be as code. So a combination of Terraform and CloudFormation for our infrastructure. Incidentally, our CloudFormation is stored in Terraform so that we have everything in one place. Now you laugh, it does make things a lot bloody easier. But when the first time we did it, we did think it was a bit odd. We use Ansible for deployments, build specs, whether that's Bamboo specs or Jenkins file to be able to do our builds, and finally Docker for everything. And I say everything because I've had quite a few people come to me and go, I've got this Java project, I've got this Python project, I want to run it. It's like, okay, cool, right, fine. And my team has to deal with a lot of different projects. A lot of these, all those different codes. So they say, oh yeah, right, can you install this? Yeah, if you want me to. It's now gotten to the point where I've got 2 busted versions of Java and 3 busted versions of Python on my laptop. I couldn't use AWS CLI, I couldn't use Ansible, I've had to revert to installing them on Brew because I just couldn't get it fixed. So after that, twice with Java, I said, don't come back to me until it's in Docker. I don't ever want to have to keep installing things. So personally, that's what I prefer, and I'm more than happy to be proven wrong, but that's where we are. So with that in mind, this is where we're trying to go to, and I've just realized how bright that is. So as it says up there, this is not just something we just plucked out of the air. It was not like that. This took many, many iterations to get to. And any of you that may have seen walking down the corridors, there is a wall that has a lot of these diagrams on it. I really wish I kept all of the iterations so that I can make a GIF with them, because there were so many. But like, so what do we encounter during this? And don't worry, some of this I will go into a bit more detail because that's kind of why we're here. You're probably not here to kind of hear about our infrastructure. Well, you are, it's DevOps. We had to make application logic changes because a lot of it was done to work with the specific infrastructure. So we need to make changes to be able to make it work with anything. But if we decide to make all this change again, we don't want to be back in the same position again. Load balance and namespacing, that was a weird one, because an API was expecting to go to, like, I don't know, user.api.com/user/1. With a namespace in an ALB, you then had to get your service on a namespace, which meant the request no longer worked because you had /user/API/user/1. So we had to resolve that. And in the work in progress stuff, you can see we've got an NLB. So we get around that with ports instead of namespacing. Well, different kind of namespacing. We've also had to do a VPC migration through this as well. Everything was in an old VPC that was not in code. So a lot of it was done by hand. It's caused a lot of troubles. And we are migrating to a lovely new shiny VPC that's all terraformed, CloudFormation wherever needed. I don't think there is any in that, but we've had to do that. So rather than doing a big bang migration, we've had to do VPC peering as well. Now, if no one's done this before, I'll give you one bit of information for free. If you try and connect from one VPC to an NLB in another VPC, it does not work. AWS does not support it. There is no way, no how to do it. So if you're thinking of going down that route, stop. No.
Yes.
Nope. No. AWS does not support connecting to an NLB in any way, shape, or form. I really wish I got the link to put up here.
That's the principle.
Sorry?
Of the VPC links is to allow you to connect to the NLB behind it and provide that as a service to another account.
Not between VPC peering.
No, without VPC peering.
Anyway. can't believe
It's private link, although it's newish.
We'll talk later. Obviously, along the way, we've had other issues as well. I really wasn't expecting that to happen. So obviously with this, it's all good and well. How are we going to do it? What are we going to do? Like, we've got all of these projects, we've got all of this infrastructure. How the hell are we going to go about doing this? And it was actually quite easy to cut this up into different sections. We have our portal section, which deals with the web-facing applications. We've got an API section that deals with the APIs. And we've got our projects along the bottom. I've only highlighted one, but they're individual projects. And that's what I was talking about earlier. With all that infrastructure, we try and reduce it. The work in progress stuff is because we have not finalized this yet, because we don't actually have something that does client-side calls, but we're trying to think ahead. So it is not finalized, like React Apps, for example, does client-side calls to APIs. We haven't had that need yet, but we're thinking about it. We're trying to think about the future and all that jazz. So.
Sorry, quick question. For the maintenance page, are you doing the change distribution list in CloudFront or using WAFs?
Hold that thought.
Yeah, that will be a great point.
So what I've just given you is a very high overview of some of the changes we've got. And as I said, I hope you kind of appreciate how big a change that is, whether it's application level, infrastructure level, all of this kind of stuff. So I'm going to talk about, I think it was 3 of these parts. And to be honest, you read maintenance mode, oh, that's going to be boring as hell. It was actually one of the most interesting problems we had to solve.
Yeah.
So the criteria for this, to allow someone, possibly non-technical, like a product manager or someone like that, to enable and disable maintenance mode instantly. As I said before, we were able to do this on our proxy server. We were able to do it instantly by just hitting a script and it would work. And this is probably highlighting what you were just asking. Using and updating CloudFront is not an option. We are not waiting 45 minutes for a maintenance page to turn on. So how do we go about doing this? We had to do quite a few iterations. The first one was a DNS failover. That doesn't work because CloudFront will let you put an alternate CNAME on one CloudFront distribution. Yep, you get errors. You get errors if you try and put the same domain on 2 different CloudFront distributions. So if you then try and switch your DNS record to a different CloudFront distribution, CloudFront decides to be magic, and it will ignore your DNS record and find the CloudFront distribution that the alternate CNAME is for. It took us a day to figure this out, and it was relieving and frustrating at the same time to actually find this. No idea why AWS does this, but it is what it is. So we're like, right, that option's no good. What can we try next? Load balancer routes. Removing them. So we have Terraform that will add in a load balancer route here for a particular service. The idea was we would use CloudFormation to remove that route when we want to go into maintenance mode and then add it back in when we want to come out of maintenance mode. But there was some kind of intricacies in that didn't feel quite right, and then we'd have to take out all of the routes, add them all back in, so we'd have to keep a log of what was there beforehand, and so on and so on and so on. So like, okay, it's viable, but maybe there's a better way of doing it. So then we tried WAF. WAF works. Works brilliantly, actually. If you get CloudFormation to update WAF to block all, it's instant. However, it returns a 403, which means you then need to get CloudFront to kind of translate that into a 503 and pass it along. Same again, it's like, yeah, it works. But there's something that's not quite right about it. What if we've got a reason there's actually a valid 403 and we suddenly start showing the maintenance page? It's going to be a bit of a weird experience, right? So then we came to Lambda Edge. Again, in principle, this sounded fantastic. We figured we'd do a Lambda that had an environment variable that we could then get CloudFormation to switch instantly again. Next nugget of information for you. Lambda at Edge does not support environment variables. I told you maintenance mode is oddly interesting for problem solving. It's like, this should have been easy. So then we was like, right, okay, so how can we do this with Lambda without doing environment variables? And then there was this idea that we'd end up having a request going to CloudFront that would go to Lambda at Edge, that would go to SSM, to come back to Lambda, to come back to CloudFront, then either go do something or hit the maintenance page. It's like, nah, that's too many steps. It's not good enough. So then finally, we came up with load balancer routes, again, but adding this time. So ALBs, I don't know when this feature came in, but it definitely wasn't here when we started all of this, allows you to return kind of like plain responses, like just a straight off response from the load balancer. Like, great, we can return a 503, we add one entry at the top of the load balancer, job done. It worked beautifully, until CloudFormation does not support these yet. You should have seen some of the devs for this. It's like AWS is against us. However, we did find a way around this. So we have gone with load balancer routes, and we've got CloudFormation working with it. But what we've got is, we've got an empty target group that has no instances in it whatsoever, and we've got CloudFormation creating a route at the very top that's just star, any single route goes to this empty target group. Instantly you get a 503, flies back up the CloudFront, and you get your maintenance page. Oh, it's a glorious day when we got that working. And that was last week. I was not expecting applause during this.
We'll all be there.
And now hopefully you won't be. Next one, environment variables. And don't worry, I am leading up to container orchestration. All of this is kind of getting to there, because it's not something you can just turn on. It's more complicated than that, especially when you had our original infrastructure. So environment variables. The criteria for this one. Variables must be stored in a secure location outside of code, so not in source control anywhere, and pulled into the container, not the image. Now, the image is an easy one. We can do that, easy as hell. But we didn't want to do that. What happens if we want to run that image in a different environment, run it with a different product, so on and so on and so on? We want to be able to make this more and more flexible. So the first step was figuring out where we're going to store these things. Now, if anyone says console to me, yeah, fine, it works. We just didn't want the hassle of trying to spin up more infrastructure. Why bother when AWS has already got SSM? Now, by all means, SSM may not be like what we use in a year's time, probably something else. It may be their console has something that succeeds it. But for right now, all we needed was somewhere to store some variables, either as plain string or secure string. So we got that. Brilliant, done. The next part, we had to update Docker. Now, we've got a duplication of Docker image commands. So looking at that one at the top, that's as a node image, just for an example. If we then have a Python one, we then got to put those same commands into that Python one, Java, so on and so on and so on. So it was kind of like, well, we need to address this. And it's not just the different languages, it's the different projects as well. So if we've got like 10 node projects, we've got 10 projects with that same bit of code in it. And it was proven to be a bit of a headache. So the first thing we did was creating base images, which is what that one at the top actually is. It's basically just a base image. It doesn't really do particularly much, but then our projects can extend it and they've got all of our default settings in it. Great, that's that one solved. We realized we needed some sort of script, an entry point, to be able to pull these things in from SSM. But we had exactly the same problem. We had that script copied into different repositories over and over and over again. So when we found a bug, we had to go do a search in all our repositories, try and find it. It did not go down well when we found a bug.
Might be too late, take a look at Chamber.
We'll talk later. And the last one, this is just kind of something else we ran into. Using Alpine images at least, I don't know if it was the non-Alpine ones as well, but we had to install certificates to actually be able to run with SSM. Again, it was just kind of like just nuances type thing. It wasn't really a difficult one to do, but just there you go. If you run into a problem, you install the certificates and it carries on. So our first attempt was using Bash. Started out quite simple, probably about that. Like fisherman's tale, this one. Probably about that, but quite quickly went to that. Sorry, that. And it wasn't very maintainable. It required a lot of dependency. So again, the one at the top, you can see that we're installing JQ, Python, pip, make, bash, curl, all of this stuff, just so we could use a bash script. Now, again, we'd have to install those dependencies everywhere. And if we were using Alpine, we have to install bash and it's like, no. We need to think about this again. And lastly, it was tricky to test. I mean, if anyone knows how to test bash efficiently, please let me know. No, don't actually, don't. So we changed our mind. It was like, right, how can we do this? How can we do this? It's going to run every single environment with a decent amount of testing and all of the bits and pieces. We decided to go for Go. Now, this came out of a Friday afternoon innovation session. It was like, we weren't really looking for it for this reason, but because we'd done some other work with Go for a different reason, it was like, maybe this would be a good fit. And straight away, it was simple, it was small, and it stayed simple. The dependencies in Docker disappeared. We didn't need any of them because we compiled our binaries. It was cross-platform. So granted, we're in Docker, so it's typically Linux, but we were able to create OS X binaries, we were able to create Windows binaries, because we had to. The reason I mentioned the cross-platform thing is because we're now actually considering Go a lot more for a lot more of our dev tools. So we're moving to like STS to be able to log into the AWS CLI, for example. There's a lot of hoops you've got to jump through to actually get there. So it's like, well, if we build a Go script that we can distribute around our devs later, can he sit at the back next time we do this? I've lost my train of thought now. The idea was we would be able to do a lot more with Go, lots of small scripts, we had to do very particular things that we could actually distribute out to people. Now, I hope I don't get in trouble for this, but it also has kind of gone down the route of potentially doing things open source. We're not there yet, but it puts us in a position where we can actually start doing those kind of things. Not just the code itself, being able to distribute the tools that we make. That would be great. I would love to be in a position where we could do that, but we're not quite there yet. So you can now see the Docker image at the bottom. This does exactly the same thing at the top, but what we're doing is we're pulling in our Go binary from a remote location. So again, we've lost that duplication of code. We are modding it to be able to be executable. We're running the entry point, we're running the command. Brilliant. I'm sure all of you know this, but if you change your entry point, you do need to reset your command. We were quite surprised by that one, but is what it is. There you go. Lastly, container orchestration. So we went with ECS Fargate. Criteria for this, reduce the amount of infrastructure each project has to create. We originally, if you do go actually manage to see all of our iterations of our plans for this, we originally proposed to do this work next year, like even Q2 next year. It was like, we've got to do a lot of phases to get to the point where we're going to be ready to be able to do this. We implemented it last quarter. Once we'd done all these prerequisites for like the maintenance page, the Docker images, all of this kind of stuff, we just kind of went, oh, actually this has just become a lot easier. And we can do this alongside our existing infrastructure. So we can do all of this while affecting no one else. So we can test the hell out of it. No one's going to know until we flick a switch. Oh, wrong button. So we've actually now started our migration to ECS Fargate and all of that new infrastructure. We actually started it this week. Getting there, it's going well. No downtime so far. I'm hoping it stays that way. So at this point now, the project creates very minimal infrastructure. And the reason the infrastructure is in quotes is because it is creating things in AWS, but it's not necessarily infrastructure. So for example, it creates an ECS service. A service on its own does nothing. It's just a shell to be able to put containers into. It also creates the load balancer target group, which again is just an empty shell to be able to put your containers into once they're in ECS. And it creates the route on your load balancer, and this is all done with Terraform. And it's lovely. I mean, this is essentially what our infrastructure looks like within the code now. It creates an ECR repository, or an EC repository, and then we have the container. That's it. And we get blue-green deployments out of the box, which was lovely, because we didn't have it before. We did, actually, that's a lie. We did have it, but we had to like hand roll a lot of this to be able to do blue-green deployments using things like Ansible. So if you remember those two containers at the beginning, we would take the EC2 out of the load balancer, which meant there was only one left. We would then update the container in there, put that one back, take the other one out, do the same, put it back. It worked fine, but it was obviously, there was a slight bit of risk to it. With this one though, I don't know if people haven't used Fargate, the task definition gets updated, the service gets updated with that task definition. Let's say you've got three containers running within your task definition. It will start up your new containers with your new code. It will make sure all 3 of those are running. Once it's happy with that, it will then start kind of draining the old containers, and once they're drained, takes them away. It's lovely, absolutely lovely. Another thing that was kind of not found by accident, we knew Fargate had service discovery, but it wasn't something we were initially planning on using. But with the work in progress stuff on the APIs, service discovery actually became very, very useful very, very quickly for a number of reasons. One, there was less infrastructure for us to worry about. Secondly, it took another layer out of your request. Because if we were going to a Route 53 record and then a load balancer, so on, so on, so on, this one is straight to the DNS record, straight to one of the containers. So we've got that rolled out on everything now. The other good thing about service discovery is it helps us with our maintenance mode. So if we turn maintenance mode on CloudFront, we can still access our services behind it by using service discovery. So before I do go to questions, although I'm hoping someone's run out, this is just, have you been taking notes? I really want a beer. This is just the tip of the iceberg. Like, I mean, you've seen what we're doing. Like, this is one particular project, but this is a big thing. But it's not the only thing we're doing. Like, part of like the next bit after that is like, how do we go multi-region? We got asked the question, can we do master-master replication? And we all just went. However, it looks like we are going to try and figure out a way of at least looking like we're doing master-master replication, but it may not in fact be master-master. We're obviously trying to split out that monolith. We're doing all sorts of bits and pieces. Like, there is so much that we are doing. So that's what I've managed to talk about today.